Alright, these are your notes on inverse functions and how to find inverse functions. Now when we're talking about inverse functions, there is one big idea, and we're going to look at it using an example, a linear example in function notation, and we're going to look at it graphically. But both of them basically have the same idea. The big idea is that you switch the domain and range. They swap. Now again, your domain is your x values and your range is your y values. So another way of thinking about it is that you're switching the x and the y. The first big idea definition we wrote there, that works for graphic organizer on a coordinate plane if we're looking at it graphically. The second one is when we're looking at it in function notation, or looking at it in slope-intercept form, if we remember back to our other classes, slope-intercept form. But the big idea is that the domain and range are switching. Now one thing you want to remember is it may be the original may be a function, but the inverse may not. Okay? Which makes sense. We're switching the domain and the range. And at the end of these notes, I'll give you a quick way to think about how to realize if our inverse would be a function or not without actually having to graph it or switch the x and the y. But first we're going to look at it in function notation. Now we use f of x in function notation. That would be the name of our function. If we're talking about the inverse, it's f to the negative 1 of x. That stands for the inverse. Mathematically, that represents the inverse function. That's how we would name it. The inverse of x. Now to do that, if we're going to find it, what we would do is we'd switch the x and the y. Alright? So here's our example. We have f of x equals 2x plus 3. Now, we've learned that f of x is really just y. It's another way of saying y, the answer. So we could rewrite this as y equals 2x plus 3, which gives us an x and a y value. Now we're going to follow our rule. The big idea says to switch the x and the y. So we end up with x equals 2y plus 3. Now we want to manipulate this so it's back to y equals. That way we can swap the y out for the f of negative 1 of x, the inverse of x, okay, or the inverse function of x. So let's look at that. So we want to get it to y equals. I'm going to rewrite x equals 2y plus 3. Well, our first move would be to subtract 3. That would give us x minus 3 equals 2y. Now y still isn't by itself, so we're going to divide everything by 2. That gives us x over 2 minus 3 over 2, because we would split that up. The denominator goes with both parts of the numerator, equals y. Now we're going to switch it so the y is on the left. We're just going to swap the sides. So y equals, and I'm going to rewrite this even farther. I'm going to make it 1/2 x, because there's really a 1 in front of that x. So we could pull the 1 and the 2 out and make it a 1/2 minus 3 over 2. And then we're going to switch the y out and make it the inverse function of f of x equals 1/2 x minus 3 over 2. And that would be how we would find the inverse function using function notation. If you notice, this would be linear. And linear functions, we've said before, have a domain and range that's always all real numbers, so it is a function. So we started out with a function here, and we ended with a function. Both the function, the original function, and the inverse were functions, and they're both one-to-one. Graphically, it's a little different. Graphically, we're going to swap the domain and the range. Now, what happens with that is really it's a reflection of the graph over the y equals x line. Now the y equals x line is a particular line on the graph where all of the x values equal the y values. X and y are the same number, so it includes the points 1, 1, 2, 2, 3, 3, 4, 4, because x and y are all the same values. It also includes 0, 0, and we can go into the negative numbers also, negative 1, negative 1, negative 2, negative 2. So it would include these points here. And graphically, what we're looking at is that would be a reflection over that line. If we folded the graph in half, our inverse would be the reflection of that. What that means again is that you would switch the domain and range. Our range now becomes the domain becomes the range. This is where it's important. This is where you could think a little bit. If you think a little farther and switch them, we've said before that the vertical line test determines whether there are repeats in the domain. It makes it a function or not. And the horizontal line test decides if there's repeats in the range and figures out whether it's 1 to 1. Well, if we're going to flip those, then our horizontal line test of our original determines whether the inverse is a function or not, because we're switching them. So our domain and range would switch with each other. And if we just look at the original graph, we could test and tell by using the horizontal line test if our inverse would be a function or not. We could go ahead and graph it, and then we would just use the vertical line test if we've graphed it already, but we don't have to graph it in order to determine the inverse, because the range would tell us that, because it's going to be our new domain for our inverse function. So if you remember that, it might save you some trouble graphing. Let's look at a quick example of how to graph over the y equals x line. And just dash the line in there where we would reflect. So let's suppose we have a point here. We're going to look at a relation, just some points. Now if we're going to reflect, these 3 points need to end up on the other side over here. So let's suppose that this first point is 3, 0. Means if we reflect it, we switch the domain and the range, it would be 0, 3 on the other side. Because we would switch the domain, we'd flip and flop the x and the y. Let's say that this point is 5, 1. So then over here, it would be 1, 5. And the last one, let's say that this is 4, 3. That would make it 3, 4. So again, you're switching the x and the y, or the domain and range. Now those are the big ideas for inverse functions. We're going to do a lot more with this in class, but you need to know the basic idea that you are switching the domain and the range, and that you are switching the x and the y value.